All right, and we're still tracking the tropics this morning. And what's really interesting is we're still looking here at this potential storm that's been developing, or it's not developing, but the models have been showing. We talked about it 2 days ago, and we're still looking at that same situation here this evening. So, model they're becoming more certain. There's still a lot of uncertainty in the forecast. Obviously, it's 7 days out, but more models are showing it. What's really interesting is now we've got a couple models developing in the Eastern Pacific instead of the Caribbean. So that would mean different impacts, different scenarios with that, and that's still at this point in the realm of possibilities. Really, in this larger area of potential development, right? Looking at the whole view of the North Atlantic right now, we've got the same similar setup as when I last talked to you guys 2 days ago. We've got tropical waves coming through here. A lot of them are dying at this point as they move through here during D minus. And we still have a larger area of convective activity and thunderstorm activity in the Eastern Pacific, Caribbean, as well as this general front of low pressure here, which has been pretty much sitting there for about a week now, I believe, on and off type of situation, and a lot of convective activity in the south here as expected during this time of the year. Okay. Looking here at this Caribbean loop here, we can see a similar story here again. We've got you can see here these tropical waves coming through, and they're going to be coming through here, some of them stronger than others, and that's going to be helping again, bringing some potentially some convection, some moisture, and some possibilities to help develop this storm in the coming days. Now, what's really interesting is obviously we're in an El Nino at this point. And as we know, El Nino usually means a more favorable situation for Eastern Pacific, and North Atlantic seems to have lower seasons, lower than average seasons, cooler sea surface temperatures, more wind shear, overall less hurricanes, right? Now, what's interesting, obviously, we're in an El Nino. Wind shear is supposedly going to be higher than usual, but sea surface temperatures are some of the highest we've ever seen in the Atlantic. Now, what's that going to mean? That's where the confusing is. Are we going to be getting stronger storms? Are we going to be getting more storms? Is this going to be an active season or not? Look at that. This is the overall North Atlantic. So, for all of March and April, it was regularly above average, and now we're jumping. It's increasing drastically every day, almost at +1 degrees. Looking at a closer look at that Caribbean. Since about April, we've been seeing this steady increase, and now in these last couple of days, it's been increasing. Very fast. And that's going to help with the storm that's supposedly going to be brushing up. And look at the MDR, some of the warmest it's ever been all year. Warmest it's ever been at this time of the year in forever, I believe. It's one of the warmest MDR we've ever seen in June. Look at that. +6 degrees. It's warming at rates we've never seen before. And this is really odd pairing this up with an El Nino season. So we're going to have to track this very closely. Let's look at these models. Obviously, MDR is where those tropical waves are coming from, coming into the Caribbean, and then this is the GFS, right? So in about 96 hours or so is when the GFS have been showing first signs of development. It's been about a week now with this showing development every day. CMC, Euro, and Icon are now getting on board with this, so we'll likely see the NHC mark this by Monday. But let's look at this here. We've got this general area of thunderstorm activity as we've been noticing and talking about, as well in the Eastern Pacific. Now, what's interesting here is GFS. It takes it straight north into the North Atlantic. Let's look over a couple days here. This is gonna be crucial. This is gonna be crucial. GFS takes it just offshore of Central America, if not onshore. If conditions push it slightly more this way, this high pressure pushes a little bit more. We've got this storm going into the east back. And that's what's going to be crucial here, whether it is going to be pulling up into the Atlantic or pulling a little farther south into the east back. Okay? That's what we're going to have to be tracking closely. But let's look at the GFS here. This is in a couple days. Look at that. We have this general area of thunderstorm activity and vorticity. It's spreading, okay? It's spreading from the Atlantic to the Eastern Pacific. It can go either way here. Look at that. And this is what's really interesting. Look at the GFS here. About 162 hours or so, we've got two low pressure systems, right? One develops in the Eastern Pacific, one develops in the Atlantic. CMC doesn't have the Atlantic one. It has all of that thunderstorm activity and vorticity go straight into the Eastern Pacific. And that's going to be similar to the Euro. Euro has that similar pattern where everything's going to be going to the Eastern Pacific here. GFS wants to takes it a little bit differently. The Eastern Pacific one ends up dying out. Okay, there's conditions are not favorable right now, and then it ends up taking the Atlantic one into this path here, bringing it north, getting pulled by an upper level ridge here, and it allows this to develop rather quickly again with these very strong sea surface temperatures, relatively low wind shear, and it does develop this into a major hurricane. Okay, 957 millibars. That's easily a Category 3 hurricane. Now this has been varying. Development has been pretty similar in the spot. Now it's been taking it anywhere from Texas to under the tip of Florida. Okay, it's been taking it anywhere from the whole northern Gulf Coast to missing Florida and going out to sea on the eastern seaboard. And that's going to be another one of those, varying. We've got development on board by all models, but we've got anywhere from taking it to the eastern Pacific to taking it out to sea or perhaps closer to the North Carolinas to taking it to Texas. So this is, we've got a lot of different possibilities with this system here. Let's look at the GFS here. Takes it under the tip of Florida and then ends up getting pulled by that ridge here, pushes it, or that high pressure system pushes it pretty fast into the Carolinas here. That's one possibility. If we look at the previous model here, let's look at the previous model. It took it all the way across the Yucatan Peninsula. So you see how this is varying here. Just before here, we had that high pressure here. All right, and then in that other model we just saw, the high pressure was all the way here. So that high pressure is going to be crucial in this. Let's look at the CMC model just here because it's the other one that's really we got to look at for the complete opposite scenario. Look at this here. It takes that same area of convective activity and vorticity here, and actually just brings it straight into the Eastern Pacific, develops it into a low end tropical storm here, as you can see right here, and that's rather interesting because it's another one of these possibilities. And do we see chances of development come up in both basins by the National Hurricane Center? That's just gonna, we're gonna have to see how the high pressures develop, how the ridges. Do we have any frontal systems coming down which can help push this system across the Central America? That's gonna really be key in this here. As we look really quickly at the European model, similar thing here. It does bring it into the eastern seaboard, Eastern Pacific here, just because we have these ridges, and it just has a different setup here compared to the GFS. And then the icon, it doesn't develop it just because it doesn't go out far enough yet. But it does have a setup. It does have that area of moisture and potentially convectivity, and it does have a setup with a bit of a weaker high pressure, a bit more farther east, and where would take it more into the Atlantic rather than the Eastern Pacific. So that's all I've got for you today. We're going to be still tracking this in the next couple of days. If you are anywhere at this point, Texas, uh, Eastern Pacific, the Atlantic coast, we're going to have to be tracking this closely. Right now, the uncertainty is very high. Whether it will develop, where it will hit. We've just got so much uncertainty. We can't really be alarming or predicting anything until we really see these clouds and that convection popping up in the Caribbean in about 7 days or so.